Right, good afternoon colleagues, good afternoon boys and girls. We are going to look at analytical geometry. We looked at analytical geometry this morning, the one of grade 10 and grade 11. Of course, now mainly we are going to concentrate at grade 12 analytical geometry. Please, like you did this morning, pay attention, make sure that you get as much information as possible. Like I said this morning, you know, analytical geometry is one of those topics that you must make sure that you collect as many as possible. Right now, let me just remind you quickly about what we did this morning. Of course, we looked at the gradient, we looked at the midpoint, and also we looked at the what? At the distance and the equation of a straight line. Of course, we still need this information here on the analytical geometry of grade 12. Right now, let us now start now with the analytical geometry of grade 12. Of course, here mainly we'll be concentrating on what? On the circle, on the equation of the circle. Remember now we have two types of the circle here, the one that is centered at origin and the other one that is centered at any point. Right, let us now start. When you look at this one here, we have the circle here. This circle here is centered at origin, right? This circle is centered at origin, right? What is it that is important here? Of course, we must remember now, what is the equation of the circle that is centered at origin? Of course, that will be what? R squared plus y squared plus x squared is equals to r squared. Of course, x squared plus y squared is equals to r squared. That is the equation of a circle centered at origin. Of course, now mainly here what is important is you must now remember now you must be able to do what? You must be able now to determine the equation. You must be able now to determine, number one, the equation. You must be able to determine the equation of a circle. You must be able now to determine the equation of a circle, which is very, very important. Now, when you determine the equation of the circle, what is it that you need? For you to have x squared plus y squared is equals to r squared, what is it that you need here? It is very important here. That is x squared plus y squared there is equals to r squared. Let me write it correctly, of course, because now the sign is a plus between the two. There's not much difference, but the correct way here is x squared plus y squared is equals to r squared. Good. Now, what is it that you need when you determine the equation of the circle? Of course, we agree that because this circle here is centered at origin, of course, the first thing that you need here, that will be what? That will be the radius. Of course, you need the radius of the circle, which of course is very, very important, the radius of the circle. And now number two, if you don't have the radius of the circle, of course, you need what? You need a point on the circle. Of course, from here now, you will not be able to determine the equation of the circle. Maybe just to emphasize the issue of the radius as well as the point on the circle here. If I have to make an example here, if we are given that the radius here is what? The radius here is 5. Now it will be easier for you to determine the equation, because the only thing that we need in this equation, x squared plus y squared is equals to r squared, is just to substitute r with what? With 5. Just substitute r with 5 and then you square it there. You're going to have x squared plus y squared is equals to 5 squared. Therefore, the answer there is 25. Therefore, the equation of this circle here will be what? The equation of this circle will be x squared plus y squared is equals to 25. That's when now if the radius is given, if r is equals to 5. But also, like I said, there are a situation whereby you'll find that there is a point on that circle. You find that there is a point on that circle, and now they say the coordinates of this point here, that is 2 as well as what? That is 2 as well as minus 3 here. 2 as well as minus 3. Now, what is it that you're going to do in this case? Okay, let me make it 5. Let me make it 5. That is 5 as well as minus 3 here. What is it that you're going to do in this situation here? Of course, it's more or less similar with the first one that we did, where we have what? Where we have the radius. But in this case, what is it that you must do? Of course, it's very important to say, okay, we know that the equation of the circle is r squared. And the second point, why are we saying the equation of the circle is x squared plus y squared is equals to r squared? Because this circle here, it is centered at origin. Okay, now, what is our situation now? What is it that we're going to do here? Of course, now we need to substitute this point here because we don't have the radius. If we can determine the radius, then we will be able now to have what? To have the equation. Of course, the x here, it is 5 squared, and then the y there, it is minus 3 squared. Therefore, it is equals to r squared. And then from here, you say 5 squared is what? It is 25. Minus 3 squared is 9. It's r squared. When I add it to 25 plus 9, of course, that will be what? That will be 30. 34 is equals to r squared. Now, immediately now I can see now the equation of the circle here is what? It's what? It's no, the radius here, it is r squared is equals to 34. Therefore, equation then will be x squared plus y squared is equals to 34. In this type of the questions, the only thing that you must have is to have what? Is to have r. If you have r, then it will be easier for you to have the equation of the circle. Good. This one is the first one, circle centered at origin. Now we also have a circle centered at any point, right? That is centered at any point. Of course, I can also make the same. Taking out now, we have this one here. Of course, now let me now say the center is here now. Of course, the coordinates of the center now will be what? Will be A as well as B. Of course, we have our R here. That is R. Now, the equation of this circle is what? It's x minus A all squared plus y minus B all squared is equals to R squared. X minus A all squared plus y minus B all squared is equals to R squared. Good. Now, like I said, what is important in this topic is you must be able to determine the equation. Once you know how to determine the equation, of course, the next question now can ask the midpoint, can ask about the equation of the tangent. But what is important is if you can be able to determine the equation of the center, then you will be on the safe side, right? Now, what is it that you need for you to be able to determine the equation of this circle here? Of course, remember the first one we said you needed a radius or a point on the circle. Boys and girls, it's still the same case in this one here. It's still the same case when you determine the equation. When you determine the equation here, of course, you still need what? You still need the radius. But here we are specific now to say you need to have a center. You need to have a center as well as what? As well as the radius. You need to have the center and the radius. Of course, the second one, you also need to have a center as well as a point on that line. Right. Once you have these two, then it will be easier for you to do what? To determine the equation of the circle. The difference between the two. This one, we know that the center is at origin. What about this one here? We know that the center is at any point, whereby now we will be using x minus a all squared plus y minus b all squared is equals to r squared. Of course, to add again on this one also here, we will now have to find also the equation of the tangent. We will now also have to find the equation of the tangent. Now, how do we determine the equation of the tangent? Of course, we must remember now, if we have line 1 here, this will be line 2. Now, remember now, the gradient of line 1 multiplied by the gradient of line 2 is equals to -1. Why are we saying this? We know that the tangent is perpendicular to the radius, right? We know that tangent is perpendicular to the radius. Therefore, if we can have the gradient of the radius, then it will be easier for us to find the gradient of the tangent. Why do we need this one? Because you'll remember that most of the time we say now the tangent touches the circle only what? At one point. Therefore, if you have only this point here, therefore it won't be easier for you to determine the gradient of the tangent. That is why we need the radius, because you know that the radius is perpendicular to the tangent. Now, once you have that one, now we say now m radi multiplied by the m tangent is equals to -1, and therefore now you find m tangent dividing both sides by the gradient of the radius. And therefore, once you have the gradient, therefore you remember now the equation of the straight line, y minus y1 is equals to m into x minus x1, right? Or one can also say y is equals to mx plus y is equals to mx plus c, right? This is the information that you need before you can start answering the questions under what? Under analytical geometry, especially the one of what? Especially the one of the grade 12. Right, now, I think now you have a little bit of background now under analytical geometry of grade 12 now. Let us now try to take some of the past papers now to see if now we can now be able to answer these questions here. Right.